Welcome to the introduction video for our step-by-step construction guides on how to build your polytunnel. We understand that being able to see is better than reading off a page. A picture speaks 1,000 words. This is why we have created step-by-step instructional videos detailing every part of the construction of your polytunnel. Throughout the printed instruction manual that is supplied with all polytunnel orders, you will see QR codes. Simply scan these QR codes with your phone and you will be directed to the correct video. Upon receiving your order, we start to pick and pack your polytunnel and get it ready for dispatch. Your polytunnel will be delivered by our nationwide courier and will consist of several different packages. If you have any queries regarding delivery of your polytunnel, please visit www.firsttunnels.co.uk/shipping. Throughout the construction of your polytunnel, you'll be using a variety of steel tubes at various lengths. Identifying the steel tubes is easy. Taking this code for example, 50/120FS. The first number indicates the diameter of the tube, and the second number indicates the length. The two letters that precede the numbers indicate the finish to each end. F indicates flattened end, S indicates swaged end, and P indicates a plain end. For this example, the steel tube is 50 mm in diameter and 1.2 meters long, with one flattened end and one swaged end. The next video in this playlist will be how to set the foundations for your polytunnel. In this video, we will show you how to set the foundations for your polytunnel using concrete on an earth base such as grass or soil. In this video, we will demonstrate setting the foundations for a 30-foot wide by 30-foot long polytunnel. Setting the foundations is an essential part of constructing your polytunnel. Taking your time to set your polytunnel foundations correctly will ultimately result in a more robust polytunnel that performs well and looks good. Here are the parts you'll need. All of your polytunnel foundations should be in line, evenly spaced, and consistent in height. To get started, we're going to position the four corner foundations. The swaged end of the foundation tube should be out of the ground when set. At this stage, we are temporarily positioning the foundations to make sure we have the right measurements, so only push them into the ground enough to steady them. Take all measurements from the tube centers. Choose a corner and position the first foundation. From this corner, measure down the length of your polytunnel, and position the second foundation where your polytunnel ends. It is essential that your foundations are set square. This can be achieved by ensuring that both diagonal measurements from corner to corner are equal. This measurement is different for different sizes of polytunnel. We have listed the diagonal measurements in your construction booklet. If your size isn't listed in the construction booklet, we also have a useful polytunnel diagonal calculator available online that calculates this important length. Please visit firsttunnels.co.uk/diagonal. Using two tape measures in tandem, measure 30 feet across the width from the second corner and diagonally from the first corner to position the third corner foundation. Repeat this procedure to position the final corner foundation. Finally, double check that the measurements between number 3 and 4 corners is correct for your length of polytunnel. Now your corner foundations are in position and square, you should now check that the site is level. A slope along the polytunnel's length is not an issue. However, if the site slopes across the width, then the foundation on the lower side will need raising out of the ground until they are level with the other side. This is to ensure that the hoops are vertical. We suggest that the foundations are raised no more than 15 centimeters, as you require enough foundation to be secured into the ground. We can supply longer foundation tubes if required. Please visit firsttunnels.co.uk/tube. Checking the degree of the slope can be achieved by running a taut string line from the base of a corner foundation across the width. Delicately holding a spirit level on the string line or using a line level can determine the slope. If a slope exists, you must start by fitting the foundations on the side that is the highest first. We will now show you how to secure the foundations into the ground. You will be required to measure around the foundation tube and excavate a 50 cm square by 60 cm deep hole. This means you'll be required to remeasure the position of the foundation tubes using the methods demonstrated earlier. The base of the hole can be used to hold the foundation tube in place. Protecting the swaged end with a piece of timber, knock the foundation tube into the base of the hole. The base of the swage should be set at ground level. Use a piece of timber to lay over the hole as a guide. Secure an exhaust clamp approximately 2/3 down the tube. The clamp prevents the unlikely instance of the tube sliding out of the concrete block. We suggest using concrete that is 1 part cement and 5 part aggregate. We also recommend postcrete. This ready-made mix is supplied in 20 kg bags and you simply add water. Approximately 2 bags per hole will be required. We have now shown you how to secure the first foundation in position. We will now proceed to secure the 3 remaining corner foundations. For the second corner, use 2 tapes in tandem to reposition the foundation and secure using concrete. We will now secure the third corner. The foundations on the opposite side of your polytunnel must be sat level across the width. This may require setting the foundations higher out of the ground. Excavate a hole and reposition the third corner foundation using the methods described earlier. To ensure the foundation tube is sat level across the 30-foot width, tie a string line on the second foundation tube close to the top. Adjust the height of the foundation tube to the correct level across the width. You may be required to return back some of the hole spoil to accommodate this. Once the third foundation is the correct height and position, secure it into the ground using concrete. We will now reposition and secure the final corner foundation. Excavate a hole and reposition the fourth corner foundation using the methods described earlier. Tie a string line from the first corner foundation and pull it taut across the width to ensure the fourth foundation is level with the first foundation and secure it into the ground. We have now positioned and secured all 4 corner foundations. You can now install the intermediate foundations. Use a measuring tape to position intermediate foundations at 6-foot spacings. Excavate a 50 cm square by 60 cm deep hole for each foundation. Use a taut string line between the 2 corner foundations to ensure the intermediate foundations are consistent in height and in line. Reposition the intermediate foundations in the hole and secure using concrete. Now we are ready to repeat on the opposite side. In this video, we will show you how to set the foundations for your polytunnel on a solid base such as concrete or timber. In this video, we will demonstrate setting the foundations for a 30-foot wide by 30-foot long polytunnel. Setting the foundation is an essential part of constructing your polytunnel. Taking your time to set your polytunnel foundations correctly will ultimately result in a more robust polytunnel that performs well and looks good. Here are the parts you'll need. All of your polytunnel foundations should be in line and evenly spaced. To get started, we're going to position the 4 corner foundations. At this stage, we are temporarily positioning the foundations to make sure we have the right measurements. Take all measurements from tube centers. Choose a corner and position the first foundation. From this corner, measure down the length of your polytunnel and position the second foundation where your polytunnel ends. It is essential that your foundations are set square. This can be achieved by ensuring that both diagonal measurements from corner to corner are equal. This measurement is different for different sizes of polytunnel. We have listed the diagonal measurements in your construction booklet. If your size isn't listed in the construction booklet, we also have a useful polytunnel diagonal calculator available online that calculates this important length. Please visit firsttunnels.co.uk/diagonal. Using two tape measures in tandem, measure 30 foot across the width from the second corner and diagonally from the first corner to position the third corner foundation. Repeat this procedure to position the final corner foundation. Finally, double check that the measurement between number 3 and 4 corners is correct for your length of polytunnel. In this instance, 30 foot. To fix the base plate to the floor, use shield anchors for concrete or coach screws for timber. Make a mark at each bolt hole position. If on a concrete base, drill holes 10 cm deep using a 16mm masonry drill bit. Separate the bolt and washers from the sleeves and insert through the holes in the base plates and then screw on the sleeves. Locate the sleeves into the holes and then firmly tighten using a 17mm spanner. If on a timber base, drill pilot holes 7 cm deep using a 7mm timber drill bit. Reposition the base plate and tighten the coach screws using a 17mm spanner. Repeat on all 4 corners. Remember to recheck your measurements as you proceed. You can now install the intermediate foundations. Use a taut string line between the 2 corner foundations to ensure the intermediate foundations are in line. Use a measuring tape to position intermediate foundations at 6 foot spacings, and fixing position using the same method as the corner foundations. Repeat on the opposite side. In this video, we will show you how to construct and position your polytunnel hoops. Here are the parts you'll need. During the manufacturing process, the hoops are oiled. You will be required to remove the oil with a degreaser such as hot soapy water or white spirits. This is required as the polytunnel cover will be protected from the hoops with an adhesive tape. It is easier to clean the hoops prior to assembling them. First, we will start by assembling the hoops on a flat, clear area.
The 2 legs of the hoop are plain on both ends. One arched piece is swaged on both ends. The second arched piece has one swaged end and one plain end.
Connect the sections of hoop together by slotting the swaged end into the plain end. Secure the tubes together using a self-drilling screw with the provided driver socket, 4 cm from the joint. Flip the final hoop over prior to screwing. This ensures when the hoops are positioned, the screw heads are internal to the structure and that the configuration of the hoop joints are identical for all hoops. It is normal practice for the hoops to be put under tension to get the required width. Do not assume that the hoop, when assembled, is the correct width. It will look wider until positioned onto the foundation tubes or base plates. Position an assembled hoop at one end of the structure, ensuring the screw heads are not externally facing. This will prevent damaging the polytunnel cover when fitted. Repeat the process for all hoops. In this video, we will show you how to install corner stabilisers on your polytunnel. Corner stabilisers help strengthen your polytunnel by spreading the load from the wind. Here are the parts you'll need. There are 8 corner stabilisers, 2 for each corner. The corner stabilisers are positioned between the end hoop, the first intermediate hoop, and the second intermediate hoop. Each corner stabiliser is made from 2 pieces. One piece is 1.78 meters long, flat at one end and plain at the opposite end. The second piece is 45 centimeters long, flat at one end and swaged on the opposite end.
Fit a Q-clip 18 cm up from the hoop and foundations joint on the second intermediate hoop.
Use a pair of pipe grips to close the prongs together. Locate the flat end of the longer piece to the Q-clip. Push a bolt through the hole, ensuring the threaded part is on the inside of the polytunnel. The bottom of the Q-clip should be on the 18 cm mark. Screw on a nut and firmly tighten. Slide the swaged end of the shorter piece into the plain end of the longer piece. Position a Q-clip on the first intermediate hoop and locate the flat end to the Q-clip. Push a bolt through the hole and loosely secure in place with a nut. Secure the two pieces of the corner stabilizer together with a self-drilling screw. Place the spirit level on the first intermediate hoop and adjust the Q-clip up or down until the hoop is vertically aligned and firmly tighten the Q-clip.
Measure 10 cm down from the bottom of the Q-clip fitted on the first intermediate hoop and make a mark.
Fit a Q-clip to the hoop. The top of the Q-clip should be on this mark. Locate the flat end of the longer piece to the Q-clip. Push a bolt through the hole, ensuring that the threaded part is on the inside of the polytunnel. Screw on a nut and firmly tighten. Slide the swaged end of the shorter piece into the plain end of the longer piece. Position a Q-clip on the end hoop and locate the flat end to the Q-clip. Push a bolt through the hole and loosely secure in place with a nut. Secure the two pieces of corner stabilizer together with a self-drilling screw. Place a spirit level on the end hoop and adjust the Q-clip up or down until the hoop is vertically aligned and firmly tighten the Q-clip. Repeat this process to fit the corner stabilizers on the three remaining corners of your polytunnel. In this video, we will show you how to install the ridge of your polytunnel. Here are the parts you'll need. Your ridge will be supplied in pieces of tube which slot together. There is one 61 cm piece which is plain on one end and swaged on the opposite end. The remaining pieces are 1.9 meters long and are plain on one end and swaged on the opposite end. Slot the swaged end of the short piece into the plain end of the long piece and secure using a self-drilling screw with the provided driver socket, 4 cm from the joint. This piece will be fixed in position using ridge clamps. Position a ridge clamp on the first and second hoops centrally on the apex. On the end hoop, ensure the threaded section of the clamp is to the inside of the polytunnel. Slide the ridge tube through both ridge clamps, ensuring the plain end is on the end hoop. Firmly tighten the end clamp with the plain end of the ridge tube, protruding as little as possible through the ridge clamp. Ensure the hoops are vertical. The end hoops have been set vertical when fitting the corner stabilizer. Visually adjust the intermediate hoops so they look vertical and tighten the ridge clamp. Work along, adding sections of ridge tube and securing to the hoops using ridge clamps. Secure the two tubes together using a self-drilling screw 4 cm from the joint. Ensure that all intermediate hoops are vertical and tighten the ridge clamp. The final ridge tube will exceed the length of your structure. You will be required to trim the tube so it is protruding as little as possible through the ridge clamp. The ends will be sharp. Protective tape will be applied at a later stage. In this video, we will show you how to install roof stabilizers on your polytunnel. Here are the parts you'll need. There are 4 roof stabilizers, 2 for each end. The roof stabilizers are positioned between the end hoop and the first intermediate hoop. Roof stabilizers are supplied in 2 pieces. One measures 1.78 meters long, is flattened at one end and plain at the opposite end. The second piece measures 45 centimeters long, is flattened at one end and swaged at the opposite end. First, slot 2 tubes together by placing the swaged end into the plain end. Carefully balance one end on the end hoop. Fit a Q-clip to the first intermediate hoop near the ridge. Locate the flat end to the Q-clip. Push a bolt through the hole, ensuring the threaded part is on the inside of the polytunnel. screw on a nut and loosely secure into place. Adjust the Q-clip so it is 5 cm to one side of the ridge clamp and firmly tighten the nut. Fit another Q-clip on the end hoop. Locate the second flat end to the Q-clip. Push a bolt through the hole, ensuring that the thread of the bolt is on the inside of the polytunnel, and loosely secure into place. Once in position, secure these tubes together using a self-drilling screw with the provided driver socket 4 cm from the joint. Finally, tighten the nut on the Q-clip on the end hoop. Repeat this process for the 3 remaining roof stabilisers. In this video, we will show you how to install crop bars and crop bar vertical braces on your polytunnel. Crop bars span across the width of your polytunnel on intermediate hoops, and they are used so that the structure is more robust. Crop bars are not installed on the 2 end hoops. Here are the parts you'll need. Crop bars are supplied in 3 pieces. 2 are 2.59 meters long and are flattened on one end and swaged on the opposite end. The other piece is 2.48 meters long and is plain on both ends. Connect the tubes together by locating the swaged end in the plain end. Secure the pieces together with a self-drilling screw 4 cm from the joint, ensuring that both flattened ends are in line. Fit a Q-clip onto one side of the hoop, approximately head height. Locate the flat end of the assembled crop bar to the Q-clip. Push a bolt through the hole and loosely secure in place. Position another Q-clip on the opposite side of the hoop. Locate the flat end to the Q-clip. Push a bolt through the hole and loosely secure in place. We need to ensure the crop bar is level. Place a spirit level on the crop bar and adjust accordingly. Once the crop bar is level, firmly tighten the nuts on both Q-clips. Now we will fit the crop bar vertical braces. Crop bar vertical braces span from the crop bar to the hoop. There are 2 vertical braces per crop bar. Crop bar vertical braces are 1.4 meters long and are flat at both ends. From the ridge clamp, measure 40 centimeters along the hoop and fit a Q-clip. Locate the flat end of the vertical brace to the Q-clip. Push a bolt through the hole and firmly tighten. Repeat on the opposite side. Now fit a Q-clip to the crop bar. Locate the flat end of the vertical brace to this Q-clip. Push a bolt through the hole and loosely secure in place. You may need to lift the crop bar up to do this. Repeat this on the other side. Ensuring that the crop bar vertical braces are not pushing the crop bar down nor pulling it up. Once you are happy with the level, tighten both Q-clips. Repeat this process on the remaining intermediate hoops. In this video, we will show you how to install storm braces onto your polytunnel. Here are the parts you'll need. Storm braces are only fitted to intermediate hoops, not the 2 end hoops. Storm braces are installed over the hoop joints on the inside of the hoop. Storm braces are made from 35mm diameter tube, are 45 cm long, and are flattened at both ends. Fit a Q-clip onto the hoop above the joint. Once the Q-clip is on the hoop, use a pair of pipe grips to close the prongs together. Locate one end of the storm brace on the Q-clip and loosely secure into place. Next, fit another Q-clip below the joint and secure the opposite ends of the storm brace. Adjust the position so the middle of the storm brace is over the joint and then firmly tighten both Q-clips. You can now repeat this process to fit the remainder of the storm braces on the intermediate hoops. In this video, we will show you how to install door rails, door vertical braces, and door rail stabilisers on your polytunnel, which are used to support your door frame and doors. We will start by fitting the door rail, then the door rail vertical braces, and the door rail stabilisers. Here are the parts you'll need. The door rail spans across the width of your polytunnel on the end hoops. Door rails are supplied in 3 pieces. 2 are 2.59 metres long and are flattened at one end and swayed on the other. The third piece is 2.48 metres long and is plain at both ends. Connect the tubes together by locating the swaged ends in the plain ends. Secure the 3 pieces together with self-drilling screws, 4 cm from the joint, ensuring that both flattened ends are in line. First, fit a Q-clip to the hoop above the corner stabiliser. Locate one end of the door rail to the Q-clip. Push a bolt through the hole, ensuring the thread is on the inside of the polytunnel and loosely secure in place. Position another Q-clip on the other side of the hoop. Locate the flat end of the door rail to the Q-clip and push a bolt through the hole and loosely secure in place. We need to ensure that the door rail is level. Place a spirit level on the door rail and adjust accordingly. Tighten the bolts on the Q-clip on both sides. Now we will fit the door rail vertical braces. Door rail vertical braces span from the door rail to the end hoop. There are 2 door rail vertical braces per end. Door rail vertical braces are 1.4 metres long and are flat at both ends. From the ridge clamp, measure 40 cm along the hoop and fit a Q-clip. Locate the flat end of the vertical brace to the Q-clip, push a bolt through the hole and firmly tighten. Repeat on the opposite side. Now, fit a Q-clip to the door rail. Locate the flat end of the vertical brace to this Q-clip. Push a bolt through the hole and loosely secure in place. You may need to lift the door rail up to do this. Repeat this on the other side. Ensure that the door rail vertical braces are not pushing the door rail down nor pulling it up. Once you are happy with the level, tighten both Q-clips. We will fit the door rail stabilisers. Door rail stabilisers span from the door rail to the first intermediate hoop. There are 2 door rail stabilisers per end. They are supplied in 2 pieces. One is 1.78 metres long and is flat at one end and plain at the other end. The second is 45 centimetres long, flat at one end and swayed at the opposite end. From the end of the door rail, measure 1.83 metres in and make a mark. Fit a Q-clip at this point. They are positioned so that they don't interfere with the doorpost timbers. Now fit a Q-clip onto the first intermediate hoop approximately 2 metres from the ridge clamp. Locate the flat end of the 1.78 metre piece to the Q-clip on the intermediate hoop. Push a bolt through the hole and loosely secure in place. Slide the swaged end of the 45 centimetre piece into the plain end of the 1.78 metre piece. We will secure this tube to the door rail first. Loosely secure the flat end to the Q-clip on the door rail. Whilst ensuring these 2 pieces do not separate, adjust the Q-clip on the intermediate hoop. Secure the 2 pieces together with a self-drilling screw, 4 cm from the joint. Repeat for the door rail stabiliser on the opposite side. Ensure the Q-clips on the door rail are on the 1.83 metre mark and firmly tighten. Then adjust the Q-clips on the intermediate hoop so that the door rail doesn't bow in or out of the polytunnel. When you are happy with the position, firmly tighten the nuts. You can now repeat this process on the opposite end of the polytunnel. In this video, we will show you how to install staging supports on your polytunnel. Please note, staging worktops are not supplied. However, we do supply the fixings to secure your worktop to the staging supports. We will show you how to secure your worktops with fixings at the end. Here are the parts you'll need. Staging supports come in 3 pieces.
The staging top tube is 1.2 metres long and is flattened on both ends.
The staging leg is 75 centimeters long and is flattened on one end and plain on the other. The staging diagonal brace is 45 cm long and is flattened on both ends. Connect the staging top tube and staging leg together with a 30mm M8 bolt and nut, ensuring a right angle is formed. Position a Q-clip onto the staging leg and another onto the staging top tube. Locate the flat ends of the staging diagonal brace to the Q-clips. Ensure the top tube and leg still form a right angle and firmly tighten the Q-clips. Fit a Q-clip to the hoop. Once the Q-clip is on the hoop, use a pair of pipe grips to close the prongs together. With the staging support now assembled, locate the flat end of the staging top tube to the Q-clip. Push a bolt through and use a nut to secure loosely in place. For polytunnels constructed on a soft base, we recommend that the staging leg is sat on a solid block. This will prevent the leg from sinking into the ground when you put weight on it. Now you will need to check that the staging support is level. Place a spirit level along the staging top tube to check this. Once the staging support is level and perpendicular to the hoop, firmly tighten the Q-clip. You can repeat this process for the remaining staging supports. Staging supports fitted to the end hoops will need to be slightly angled into the polytunnel, so that any worktops you fix will not interfere with the polytunnel cover. We have supplied you with fixing clamps to attach your staging tops. To attach worktops, use a 9mm drill bit to drill 2 holes through your worktop, one either side of the staging top tube. Push a bolt through each hole with the threads pointing down.
Locate the tube pressing on the bolts and secure in place with nuts and firmly tighten.
In this video, we will show you how to install twin supports on your polytunnel. As well as adding strength, they are also useful for supporting crops and hanging baskets. Here are the parts you'll need. Twin supports are assembled and fit in the same way as the central ridge. Twin supports are fitted onto the hoop at each end of the central ridge. You can choose to fit them at whichever level suits you best. In this video, we will show you how to assemble the doors for your polytunnel. Here are the parts you'll need. Constructing the doors in the warmth of your garage or on a hard flat surface is easier than trying to perform the operation on site. A door is made up of 2 uprights and 4 cross pieces. The uprights are 47mm by 75mm timber and are 2.1 meters long. The 4 cross pieces are also 47mm by 75mm timber and are 1 meter long. The remaining pieces of timber in the pack are battens, which we will use to secure the door cover to the door. To get started, we will drill 4 pilot holes in each upright with a 4mm timber drill bit. Using a tape measure, mark the position of the holes on the upright with a pencil. Holes are required 4 cm in from each end of the upright and a further 2 holes 50 cm in from each end. Ensure you drill the holes central to the width of the timber. Lay the 2 uprights parallel to each other, ensuring that the holes align, and then position the 4 cross pieces between the 2 uprights centrally with the holes. Once you are happy with the alignment, screw them together using the 150mm screws supplied in the commercial door furniture kit. We will now strengthen the joints with nail plates supplied in the commercial door furniture kit. Position a nail plate centrally across the joints and nail into place using twisted nails. Flip the door over and repeat. We will now fit the polythene panel to the door. Lay the polythene panel over the door. Ensure one edge of the panel is flush with the outer edge of one upright, and use a staple gun to secure it down to one upright. Pull the panel tight across the width and secure it to the opposite upright, ensuring there are no wrinkles or creases in the panel. Now secure the panel to one end of the door, whilst pulling any creases out. Secure the panel to the opposite end of the door. Finally, nail the battens around the frame on top of the panels. This will further secure the panels in position. The battens are 19mm by 38mm timber and come in 1.8 metre lengths. You will be required to cut battens to size. The uprights require one full batten and a shorter piece, cut to size. Position the batten flush with the inner edge of the door. Secure in position with nails approximately 20cm apart. Repeat on the opposite upright. Now measure and cut battens for the 4 cross pieces and secure in place. Trim the excess polythene off with a sharp knife. Now it is time to fix the hinges. Hinges are fixed to the inner side of the door on the 2 middle cross pieces. You'll be required to screw the triangle-shaped leaf of the hinge to the cross piece, and the rectangular-shaped leaf will be secured to the doorpost later. Position the T-hinge with the chamfered holes facing upwards, with the rectangular leaf pointing downwards. You will note that the nail plate will be visible through the holes of the hinge. You are able to drill through the nail plate with the screws provided. Adjust the position to avoid nail heads. Repeat this process for all additional hinged doors. The remaining screws for the hinge will be required once the commercial door frame has been fitted.
In this video, we will show you how to fit the door frame for hinged doors. We will show you how to secure the door frame to your polytunnel on both soil and solid bases. In this video, we will show you how to fit doors that open inwards. If you would like your doors to open outwards, this can only be done once the polytunnel cover has been fitted. We will show you how to achieve this at the end of the video. Here are the parts you'll need. The door frame comprises of 7 pieces of 100mm by 47mm by 3m timber, which are for the 4 door frame posts, the door frame lintel, and the base timbers between the door frame posts. The remaining pieces supplied in the pack are 19mm by 38mm by 1.8 metre battens, which are used later when fitting your polytunnel cover. Start by running a taut string line across the width of your polytunnel on the end hoop. Determine the centre of your polytunnel width by measuring 15 feet from the corner hoop from the centre of the tube. From this central position, measure 114 centimetres towards each corner hoop. From the central position, now measure 220 centimetres towards each corner hoop. This identifies the position of your 4 door posts. If you are fitting your polytunnel onto an earth base, you will be required to excavate a hole 30 centimetres square and 40 centimetres deep for each hole. If fitting to a solid base such as concrete or timber, the door frame post will be secured to the ground using brackets. We will show you this process shortly. We will now install the 2 inner door frame posts. Reposition one of the door frame posts into the hole or onto the solid base, ensuring the door frame post is positioned 114 centimetres from the centre mark to the inside of the door frame post. The 2 inner door frame posts will be fitted to the rear of the door rail. They will exceed the top of the door rail and will be required to cut down after fitting. To secure the top of the door frame post to the door rail, fit a P-clip onto the door rail. The prongs of the P-clip should run down the rear of the door rail and fix the front face of the door frame post where it is held in place with bolts.
Using a 9mm wood drill bit, drill through the timber on the marks.
Push a bolt through the P-clip and drill holes so that the thread is on the inside of the polytunnel. Loosely secure in place with a washer and nut. When securing to the ground, ensure that the door frame post is positioned 114 centimetres from the centre mark to the inner edge of the door frame post. It is critical that the door frame post is vertical.
Use a spirit level on the front and side face of the post. Once you are happy with the new position, tighten the nuts on the P-clip and secure the P-clip in place with a self-drilling screw. If on soil, backfill the hole with concrete. We recommend using a concrete that is 1 part cement and 5 parts aggregate. We also recommend postcrete. This ready-made mix is supplied in 20 kilogram bags, requires no mixing, you simply add water. Approximately 1 bag per hole will be required. If on a solid base, fix the base of the plate to the floor using shield anchors for concrete or coach screws for timber. Position the door frame post plate on the ground on the inside of your polytunnel. Make a mark through the center hole, then remove. If on a concrete base, drill a hole 8 cm deep using a 14mm masonry drill bit. Separate the bolt and washer from the sleeve and insert through the hole in the door frame post plate and then screw on the sleeve. Locate the shield anchor into the hole and firmly tighten using a 17mm spanner. If on a timber base, drill a pilot hole 7 cm deep using a 7mm timber drill bit. Finally, screw the plate to the doorpost using the screws provided. Cut off the excess of the inner door frame post in line with the top of the door rail. We will now fit the door to the doorpost. Ensure you leave the concrete for an adequate amount of time to set. Position the T-hinge internally onto the door frame post. Ensure the chamfered holes are visible. Use the screws provided in the commercial door frame kit to secure the hinge to the doorpost. Position the door, ensuring there is enough ground clearance for the door to fully open and close. With the first inner doorpost and door fitted, we will move on to fit the second. Position the second doorpost in the hole and loosely fix it to the door rail with a P-clip. Temporarily screw 2 self-drilling screws into the edge of the door. This will ensure that there is a consistent gap between the 2 doors and enable them to open and shut properly. Have one person hold the second door up to the first one and adjust the doorpost. Once the doorpost is tight up to the door, secure it in place by screwing the hinges onto the doorpost. It is critical that the door frame post is vertical. Use a spirit level on the front and side face of the post. With everything in the correct position, firmly tighten the nuts on the P-clip and secure the P-clip in place using a self-drilling screw. Secure the door frame post to the floor using the method demonstrated earlier. Check that both of your doors can open with enough ground clearance. If needed, adjust the height of the doors accordingly. You can now remove the self-drilling screws. We will now install 2 outer door frame posts. These are to provide additional strength to the door structure. The 2 outer door frame posts will need to be cut to size prior to securing them, as they are fitted under the door rail. Position an outer door frame post to the hole or onto the solid base. Ensure the door frame post is vertical using a spirit level. Mark the uprights of the doorpost under the door rail. Cut the post on this mark. Reposition the outer door frame post, ensuring the inner edge of the door frame post is 220 cm from the central position. Fit a P-clip onto the door rail. Both prongs of the P-clip should then run down the front face of the doorpost where it is held in place with bolts. Mark the position of the holes as before, and using a 9mm wood drill bit, drill holes through the timber. Push a bolt through the P-clip and drill holes so that the thread is on the inside of the polytunnel. Loosely secure with a washer and nut.
When securing to the ground, ensure that the door frame post is positioned 220 cm from the centre mark to the inner edge of the door frame post. It is critical that the door frame post is vertical. Use a spirit level on the front and side face of the post. Once you are happy with the position, tighten the nuts on the P-clip and secure the P-clip in place with a self-drilling screw. Secure the door frame post to the floor using the method demonstrated earlier. Secure the second outer door frame post using the same method.
We are now ready to fit the door frame lintel. The door lintel is supplied in two pieces. 100mm by 50mm timber, 3 meters long. The lintel spans between the two outer door frame posts and runs across the front face of the inner posts. Put the two pieces of the door lintel up together and join them by using a right-angled joiner, placed on the opposite corners with twisted nails. Approximately 30 nails per plate will suffice. Offer the door frame lintel up, position one end flush with one doorpost and make a mark at the other end and cut. Reposition the lintel, ensuring there is a 5mm gap between the top of the doors and the bottom of the lintel. Ensure the door frame lintel is level and use a 4mm wood drill bit to drill a pilot hole. Use a 150mm screw to secure to the doorpost. Repeat at the other side. On the inner post, drill a 9mm hole through both lintel and the inner post. Push a 110mm M8 cup square bolt through the drilled hole so that the thread is on the inside of the polytunnel. Fit a washer, then screw on the nut and then tighten. The joints can now be reinforced with nail plates on both sides. Position a nail plate equally across the joint and secure in place with twisted nails. We can now fit the timber base. This piece of timber is between the doorpost and the outer doorpost. Position a piece of 100mm by 47mm timber so it butts up with the outside edge of the inner doorframe post and runs past the outer face of the outer doorframe post. Make a mark on the base timber where it reaches the outside edge of the outer doorframe post and cut on this mark. To secure the base timber to the doorposts, drill a hole using a 4mm drill bit through the inner doorpost in line with the base timber and screw the two together with a 150mm screw. On the outer post, drill a 9mm hole through both the outer doorframe post and the base timber. Push a 110mm M8 cup square bolt through the drilled hole so that the thread is on the inside of the polytunnel. Fit the washer and screw on a nut, then tighten. The joints can now be reinforced with nail plates on both sides. Position a nail plate equally across the joint and secure in place with twisted nails. Repeat this for the base timber on the opposite side. Now we will fit the door drop spikes that keep your door from blowing in the wind. Door drop spikes are fitted to the outside face of the door on the opposite side to the hinges. Measure up from the bottom of the door 9cm and make a mark. Position a door drop spike guide bracket so the bottom of the bracket is flush with this mark. Mark the position of the two slots in the bracket and across the top. Now reposition the bracket so the bottom of the bracket is flush with the top mark and mark the position of the two slots again. Using a 9mm wood drill bit, drill a hole through the door for the 4 slots. On the inside face of the door, insert pronged T-nuts into each hole. Bolt the 2 angled brackets onto the door with the slot on each bracket at the top. Close the door to the required position, slide the drop spike down through both brackets and mark the position on the ground. Open the door and bury the tube in the required position. If your polytunnel is on a hard base, the housing tube is not required. Simply drill a hole using a 9mm drill bit to an appropriate depth. Repeat this process on both doors. In this video, we will show you how to assemble the doors for your polytunnel. Here are the parts you'll need. Constructing the doors in the warmth of your garage or on a hard flat surface is easier than trying to perform the operation on site. A door is made up of 2 uprights and 4 cross pieces. The uprights are 47mm by 75mm timber and are 2.1 meters long. The 4 cross pieces are also 47mm by 75mm timber and are 1 meter long. The remaining pieces of timber in the pack are battens, which we will use to secure the door cover to the door. To get started, we will drill 4 pilot holes in each upright with a 4mm timber drill bit. Using a tape measure, mark the position of the holes on the upright with a pencil. Holes are required 4 cm in from each end of the upright and a further 2 holes 50 cm in from each end. Ensure you drill the holes central to the width of the timber. Lay the 2 uprights parallel to each other, ensuring that the holes align, and then position the 4 cross pieces between the 2 uprights centrally with the holes. Once you are happy with the alignment, screw them together using the 150mm screws supplied in the commercial door furniture kit. We will now strengthen the joints with nail plates supplied in the commercial door furniture kit. Position a nail plate centrally across the joints and nail into place using twisted nails. Flip the door over and repeat. We will now fit the polythene panel to the door. Lay the polythene panel over the door. Ensure one edge of the panel is flush with the outer edge of one upright, and use a staple gun to secure it down to one upright. Pull the panel tight across the width and secure it to the opposite upright, ensuring there are no wrinkles or creases in the panel. Now secure the panel to one end of the door, whilst pulling any creases out. Secure the panel to the opposite end of the door. Finally, nail the battens around the frame on top of the panels. This will further secure the panels in position. The battens are 19mm by 38mm timber and come in 1.8 meter lengths. You will be required to cut battens to size. The uprights require 1 full batten and a shorter piece, cut to size. Position the batten flush with the inner edge of the door. Secure in position with nails approximately 20 cm apart. Repeat on the opposite upright. Now measure and cut battens for the 4 cross pieces and secure in place. Trim the excess polythene off with a sharp knife. We will now fit the sliding door wheels. The sliding door runs on 2 sets of wheels, screwed to the top of each door. These wheels run in an aluminium track which is bolted to the outside of the door lintel after the polytunnel has been covered. Assemble the wheels by sliding the head of the bolt onto the bracket, so that the head is in the dip in the bracket. Thread the washer face nut onto the bolt and tighten. Thread the wheel assembly onto the bolt until the end of the bolt is flush with the nylon washer. Screw the wheel assembly to the top of the door centrally and 10 cm from each end. Ensure the slot of the bracket is on the inside face of the door. The inside of the door is the side which does not have the polythene panel attached. Using a 4mm timber drill bit, drill a pilot hole for each hole and then secure the bracket to the door using the screws provided in the sliding door furniture kit. Repeat this process on the opposite side of the door. In this video, we will show you how to fit the door frame for sliding doors. We will show you how to secure the door frame to your polytunnel on both soil and solid bases. Here are the parts you'll need. The door frame comprises of 7 pieces of 100mm by 47mm by 3m timber, which are for the 4 door frame posts, the door frame lintel, and the base timbers between the door frame posts. The remaining pieces supplied in the pack are 19mm by 38mm by 1.8m battens, which are used later when fitting your polytunnel cover. Start by running a taut string line across the width of your polytunnel on the end hoop. Determine the centre of your polytunnel width by measuring 15 feet from the corner hoop from the centre of the tube. From this central position, measure 114 centimetres towards each corner hoop. Then also measure 220 centimetres towards each corner hoop from the central position. This identifies the position of your 4 door posts. If you are fitting your polytunnel onto an earth base, you will be required to excavate a hole 30 cm square and 40 cm deep for each hole. If fitting to a solid base such as concrete or timber, the door frame post will be secured to the ground using brackets. We will show you this process shortly. We will now install the 2 inner door frame posts. Reposition one of the door frame posts into the hole or onto the solid base, ensuring the door frame post is positioned 114 centimeters from the center mark to the outside of the door frame post. The 2 inner door frame posts will be fitted to the rear of the door rail. They will exceed the top of the door rail and will be required to cut down after fitting. To secure the top of the door frame post to the door rail, fit a P-clip onto the door rail. The prongs of the P-clip should run down the rear of the door rail and fix the front face of the door frame post where it is held in place with bolts. Using a 9mm wood drill bit, drill through the timber on the marks. Push a bolt through the P-clip and drill holes so that the thread is on the inside of the polytunnel. Loosely secure in place with a washer and nut. When securing to the ground, ensure that the door frame post is positioned 114 centimeters from the center mark to the outer edge of the door frame post. It is critical that the door frame post is vertical. Use a spirit level on the front and side face of the post. Once you are happy with the new position, tighten the nuts on the P-clip and secure the P-clip in place with a self-drilling screw. If on soil, backfill the hole with concrete. We suggest using a concrete that is 1 part cement and 5 parts aggregate. We also recommend postcrete. This ready-made mix is supplied in 20 kg bags, requires no mixing, you simply add water. Approximately 1 bag per hole will be required. If on a solid base, fix the base of the plate to the floor using shield anchors for concrete or coach screws for timber. Position the door frame post plate on the ground on the inside of your polytunnel. Make a mark through the center hole, then remove. If on a concrete base, drill a hole 8 centimeters deep using a 14mm masonry drill bit. Separate the bolt and washer from the sleeve and insert through the hole in the door frame post plate and screw on the sleeve. Locate the shield anchor into the hole and firmly tighten using a 17mm spanner. If on a timber base, drill a pilot hole 7 centimeters deep using a 7mm timber drill bit. Finally, screw the plate to the doorpost using the screws provided. Cut off the excess of the inner door frame post in line with the top of the door rail. Repeat this process for the second inner door frame post. We will now install the 2 outer door frame posts. These are to provide additional strength to the door structure. The 2 outer door frame posts will need to be cut to size prior to securing them, as they are fitted under the door rail. Position an outer doorframe post into the hole or onto the solid base. Ensure the doorframe post is vertical using a spirit level. Mark the uprights of the doorpost under the door rail. Cut the post on this mark. Reposition the outer doorframe post, ensuring the inner edge of the doorframe post is 220 cm from the central position. Fit a P-clip onto the door rail. Both prongs of the P-clip should then run down the front face of the doorpost. Using a 9mm wood drill bit, drill a hole through the two P-clip holes and through the timber. Push a bolt through the P-clip and drill holes so that the thread is on the inside of the polytunnel. Loosely secure in place with a washer and nut. When securing to the ground, ensure that the doorframe post is positioned 220 cm from the central mark to the inner edge of the doorframe post. It is critical that the doorframe post is vertical. Use a spirit level on the front and side face of the post. Once you are happy with the position, tighten the nuts on the P-clip and secure the P-clip in place with a self-drilling screw. Secure the doorframe post to the floor using the method demonstrated earlier. Secure the second outer doorframe post using the same method. We are now ready to fit the doorframe lintel. The lintel spans between the two outer doorframe posts and runs across the front face of the inner posts. The doorframe lintel is supplied in two pieces, of 100mm by 50mm timber, 3 meters long. Put the two pieces of door lintel up together and join them together by using right-angled joiners, placed on opposite corners with twisted nails. Approximately 30 nails per plate will suffice. The doorframe lintel should be at the height of 2.17 meters from the ground to the bottom edge of the lintel. Measure up the doorpost 2.17 meters. If your site slopes across the width, measure up the post on the higher side. Offer the doorframe lintel up, position one end flush with one doorpost and make a mark at the other end and cut. Reposition the lintel. Ensure the doorframe lintel is level and use a 4mm wood drill bit to drill a pilot hole. Use a 150mm screw to secure to the doorpost. Repeat at the other side. On the inner posts, drill a 9mm hole through both the lintel and the inner post. Push a 110mm M8 cup square bolt through the drilled hole so that the thread is on the inside of the polytunnel. Fit the washer and screw on a nut, then tighten. The joints can now be reinforced with nail plates on both sides. Position a nail plate equally across the joint and secure in place with twisted nails. We can now fit the base timber. This is a piece of timber between the doorposts and the outer doorpost. Position a piece of 100mm by 47mm timber so it butts up with the outside edge of the inner doorframe post and runs past the outer face of the outer frame doorpost. Make a mark on the base timber where it reaches the outside edge of the outer doorframe post and cut on this mark. To secure the base timber to the doorposts, drill a hole using a 4mm drill bit through the inner doorpost in line with the base timber and screw the two together with a 150mm screw. On the outer post, drill a 9mm hole through both the outer doorframe post and the base timber. Push a 110mm M8 cup square bolt through the drilled hole so that the thread is on the inside of your polytunnel. Fit the washer and screw on a nut, then tighten. The joints can now be reinforced with nail plates on both sides. Position a nail plate equally across the joint and secure in place with twisted nails. Repeat this for the base timber on the opposite side. We will now fit the sliding door track. The sliding door track is supplied in two pieces and is screwed to the underside of the doorframe lintel. To make fitting the track and doors easier, we will fit one half of the track Slide both doors along with the door stops and then fit the second half of the track where we can simply pull the door along. First, measure the width between the two inner doorposts and make a mark on the door frame lintel in the centre. Position one piece of sliding door track so that one end is butted up to the centre mark. Do not be concerned that the track does not reach the outer door frame post. Ensure it is flush with the front face of the door frame lintel and screw into position through the 4 pre-drilled holes on each piece of track. Now we are ready to position the door stops and doors onto the door track. Door stops prevent the door from rolling out of the track. 4 door stops are provided, 1 for each end of the track and 2 additional stops in the middle of the track. Assemble the door stop by screwing the slotted grub screw through the bracket and into the rubber stop. Slide 1 door stop down the track, then slide 1 door onto the track, followed by 2 more door stops, the second door and then the final door stop. We will reposition the door stops once we have fitted the second piece of sliding door track. Butt the second piece of sliding door track up to the previously fitted piece and fix in position using the supplied screws. Slide the doors to the central position. You may need to adjust the doors to the correct height. You can do this by tightening or loosening the wheel assembly. Adjust each stop by releasing, sliding along, and then retightening until the door stop is in the required position. We will now fit the door guide. The door guide prevents your sliding door from swinging in the wind. Assemble the door guide by screwing on the flange nut onto the threaded rod, with the flange at the top. Slide on the nylon roller and secure with a locking nut. You will need to hold the rod with grips to hold it tight while screwing on the locking nut. Do not tighten the nut completely. Allow the roller to turn. Position the door guide in line with the door frame post which the door slides past. Making sure it is upright, drive the guide into the ground. You will be required to repeat this process for both doors. If you have a hard base, fix a door frame post plate to the floor. Now we will fit the door drop spikes that keep your door from blowing in the wind. Door drop spikes are fitted to the outside face of the door on the opposite side to the door opening. Measure up from the bottom of the door 9 cm and make a mark. Position a door drop spike guide bracket so the bottom of the bracket is flush with this mark. Mark the position of the 2 slots in the bracket and across the top. Now reposition the bracket so the bottom of the bracket is flush with the top mark and mark the position of the 2 slots again. Using a 9mm wood drill bit, drill a hole through the door for the 4 slots. On the inside face of the door, insert pronged T-nuts into each hole. Bolt the 2 angled brackets onto the door with the slot on each bracket at the top. Close the door to the required position, slide the drop spike down through both brackets and mark the position on the ground. Open the door and bury the tube in the required position. If your polytunnel is on a hard base, the housing tube is not required. Simply drill a hole using a 9mm drill bit to an appropriate depth. Repeat this process on both doors. In this video, we will show you how to fit the aluminium base rails to your polytunnel. Unless you have decided to install side ventilation on your polytunnel, Base rails are used to attach your polytunnel cover to ensure a secure and tight fit. Here are the parts you'll need. The aluminium base rail is made up of lengths of aluminium rail, which are 61 cm, 1.83 meters, and 3.66 meters. The base rail fixes to the outside of the framework with the T-slot internally facing and the cover fixing channel towards the bottom. It is attached to the framework using intermediate clamps and corner clamps. We will start by fitting the base rail from the doorpost to the corner hoop. You will need two pieces of base rail, one piece 61 cm long and one piece 1.83 meters long. Join the two pieces together. Slide half of the rail joiner onto one piece of the base rail and tighten the screws using the Allen key provided. Then slide the second piece of the base rail onto the rail joiner and tighten the screws. This piece will extend beyond the width of your polytunnel and will be trimmed to size at the end. The 61 cm, 1.83 meter, and 3.66 meter lengths will be used down the length of your polytunnel, corner to corner.
If your polytunnel has a slope across the width, then we suggest fitting the rail on the side that is highest first. Your foundations will have been positioned at a consistent height, and consequently, the swage joint can act as an indicator for the position of the rail. Set the base of the rail in line with the joint on the foundation.
Fit a corner clamp to the corner hoop.
To assemble, place the U-bolt around the corner hoop with the threads pointing to the inside of the polytunnel. Place the tube pressing, then corner clamp onto the threads, ensuring the corner clamp wings run parallel to the width and length of the polytunnel and loosely secure in place. Position the base rail on the front face of the doorpost with the bottom of the rail also in line with the joint on the corner hoop. Ensure the rail is level using a spirit level.
Mark the doorpost in line with the T-slot and in the centre of the doorpost. Use a 9mm wood drill bit to drill a hole through the doorpost. Slide a 90mm M8 bolt into the T-slot and then through the pre-drilled hole. Fix in place using a nut and washer, ensuring the end of the base rail is flush with the inner edge of the doorpost. To fix the base rail to the corner clamp, slide a 16mm M8 bolt into the T-slot of the rail and through the corner clamp and loosely secure into place. While using the level, move the corner clamp up or down to make it level, then tighten the nuts on the corner clamp. Tighten the bolt that secures the base rail to the corner clamp. We will now fit the aluminium base rail down the length of your polytunnel. Starting with the 61cm length, slide a 16mm M8 bolt down the T-slot and locate the bolt through the corner clamp. Butt the base rail up to the corner base rail and tighten the nut. You will now start to use the 3.66 meter lengths of base rail. Depending on the length of your polytunnel, you may have been supplied with a 1.83 meter length, which will be used last. Join this length to the previously fitted length using a rail joiner. To secure the base rail to the intermediate hoop, slide two hexagon bolts from the intermediate clamps down to the T-slot of the base rail.
Position them at either side of the hoop. Place the curved pressing over the bolts and tighten.
Repeat this procedure until you reach the end of your polytunnel. The final piece will exceed the length of your polytunnel and we will trim this off at the end.
To fit a base rail between the corner hoop and doorpost on the opposite end of your polytunnel, join a 61cm piece and 1.83 meter piece and hold it in position. You will need to cut to size. Secure it to the corner clamp and doorpost using the same method as described earlier.
Where the base rails exceed the width and length of your polytunnel, cut off the excess with a hacksaw. The sawn edges will be sharp. It is important that these are filed smooth before the cover is fitted for safety and so that they don't damage the polythene cover.
We can now fit the base rail on the opposite side. If your ground is not on a slope, then repeat the procedure you followed for the first half. If you have a slope across the width, fitting the rail on this joint will create an unnecessary gap. We advise setting the base rail at a height that eliminates the gap as much as possible but still ensuring that the rail from the doorpost to the corner hoop is level. Ensure that the rail is at a consistent height. A string line will be handy here.
In this video, we will show you how to fit the aluminium side rail with ventilation to your polytunnel. Here are the parts you'll need. The aluminium side rail is made up of lengths of aluminium rail, which are 61 cm, 1.83 meters, and 3.66 meters. The side rail fixes to the outside of the framework, with the T-slot internally facing. It is attached to the framework using intermediate clamps and corner clamps. We will start by fitting the side rail from the doorpost to the corner hoop. You will need two pieces of side rail, one piece 61 cm long and one piece 1.83 meters long. Join the two pieces together. Slide half of the rail joiner into one piece of the side rail and tighten the screws using the Allen key provided. Then slide the second piece of the side rail onto the rail joiner and tighten the screws. This piece will extend beyond the width of your polytunnel and will be trimmed to size at the end. The 61 cm, 1.83 meter and 3.66 meter lengths will be used down the length of your polytunnel, corner to corner. The side rail should be fitted so it leaves a gap of 75 centimeters between the top of the base rail and the bottom of the side rail. Make a mark on the top and the bottom of the side rail. Carefully pull to the side to reveal the doorpost and make a mark on the doorpost in line with the T-slot. Use a 9mm wood drill bit to drill a hole through the doorpost. Slide a 90mm M8 bolt into the T-slot and then through the pre-drilled hole. Fix in place using a nut and washer, ensuring the end of the side rail is flush with the inner edge of the doorpost. Fit a corner clamp to the corner hoop. To assemble, place the U-bolt around the corner hoop with the threads pointing to the inside of the polytunnel.
Place the tube pressing and then corner clamp onto the threads, ensuring the corner clamp wings run parallel with the width and length of your polytunnel. Secure in place with nuts, finger tight.
Slide a 16mm M8 bolt into the T-slot of the rail and through the corner clamp. Secure the side rail to the corner clamp using a nut. Move the corner clamp up or down so that the bottom of the side rail is 75 cm above the base rail and firmly tighten the corner clamp nuts. We will now fit the aluminium side rail down the length of your polytunnel. Starting with the 61 cm length, slide a 16mm M8 bolt down the T-slot and locate the bolt through the corner clamp. Put the side rail up to the corner side rail and tighten the nut. You will now start to use the 3.66 meter lengths of side rail. Depending on your length of polytunnel, you may have been supplied with a 1.83 meter length, which will be used last. Join this length to the previously fitted length using a rail joiner. Slide half of the rail joiner into one piece of the side rail and tighten the screws using the Allen key bit provided. Then slide the second piece of the side rail onto the rail joiner and tighten the screws. To secure the side rail to the intermediate hoop, slide two hexagon bolts from the intermediate clamp down the T-slot of the side rail.
Position them at either side of the hoop. Place a curved pressing over the bolts, measure 75 cm up from the side rail and tighten.
Repeat this procedure until you reach the end of your polytunnel. The final piece will exceed the length of your polytunnel and we will trim this off at the end.
To fit the side rail between the corner hoop and doorpost on the opposite end of your polytunnel, join a 61 cm piece and 1.83 meter piece and hold it in position. You will need to cut to size. Secure it to the corner clamp and doorpost using the same method described earlier.
Where the side rails exceed the width and length of your polytunnel, cut off the excess with a hacksaw. The sawn edges will be sharp. It is important that these are filed smooth before the cover is fitted, for safety and so that they don't damage the polythene cover. If you have ordered aluminium side ventilation for both sides of your polytunnel, repeat this process on the opposite side. The next part of this process is to install the ventilation netting. However, it is best to fit the ventilation netting after the polytunnel cover has been fitted. This is because during the process of fitting the cover, the rails are raised. The cover is attached, and then the rails are lowered to add extra tension. Fitting the ventilation before this cover has been fitted will hinder the process and will result in the ventilation netting being baggy. Please watch the video, Fitting Polytunnel Cover to Aluminium Rail, and then return to this section to perform the final bit of your ventilation netting. To fit the ventilation netting, start by rolling it out down the length of your polytunnel and ensure there's enough overhang at either end. The green netting is secured to the side rail using the U and T profiles, which will need cutting to size. Measure and cut a piece of U profile to fit between the doorpost and corner clamp. Position the netting over the channel and secure in place by pushing the U profile onto the channel. Measure and cut a piece of T profile to fit between the doorpost and clamp, and then hammer this into place using a rubber mallet. Now work down the length, adding sections of the U profile to secure the ventilation netting to the side rail. Then from the final corner to the doorpost. Hammer the T profile into place, ensuring it covers any joins in the U profile. Repeat this procedure to secure the ventilation net to the base rail. It is best to start in the centre and work outwards to both ends. Pull the net down while doing so to tension. Using a wooden batten, measure and cut a piece that fits between the base rail and the side rail on the doorpost. Tension the netting and then secure to the doorpost using nails. You can now trim off the excess. Repeat this procedure on the opposite side of your polytunnel if you have ordered aluminium side ventilation for both sides. In this video, we will show you how to fit the timber base rails to your polytunnel. Unless you have decided to install side ventilation on your polytunnel, base rails are used to attach your polythene cover to ensure a secure and tight fit. Here are the parts you'll need. Timber base rails are 47mm by 75mm, commonly known as 3x2, and supplied in lengths of 1.8 metre, 2.4 metres, and 3.2 metres long. Base rails fixed to the outside of the framework. They are attached to the framework using intermediate clamps and corner clamps. We will start by fitting the base rail down the length of your polytunnel.
If your polytunnel has a slope across the width, then we suggest fitting the rail on the side that is highest first. Your foundations will have been positioned at a consistent height, and consequently, the swage joint can act as an indicator for the position of the rail. Set the base of the rail in line with the joint on the foundation. Fit a corner clamp to the corner hoop. To assemble, place the U-bolt around the corner hoop with the threads pointing to the inside of the polytunnel. Place the tube pressing, then corner clamp onto the threads, ensuring the corner clamp wings run parallel to the width and length of the polytunnel and loosely secure in place. Locate a 3.2 metre length of timber and position it down the length of your polytunnel so that one end is flush with the end of your polytunnel.
Ensure the wing of the corner clamp is in the centre of the timber, and that the timber is on the outside of the corner clamp wing, and make a mark on the timber through the corner clamp wing. Drill a hole through the timber on this mark using a 9mm timber drill bit. Push a bolt through the timber and corner clamp, ensuring the thread is on the inside of the polytunnel, and secure it in place with a nut. To secure the base rail to the intermediate hoop, use an intermediate clamp. Drill a hole through the timber on each side of the hoop using a 9mm timber drill bit. Place a bolt through each of these holes from the outside. An arched pressing is placed over the bolts and secured in place with nuts. To add another section, you will need to join another piece of base rail to the one you have just fitted. To join the pieces of base rail, you will be required to fit a nail plate to each side of the joint. Position a nail plate equally across the joint and secure in place using square twisted nails. Work down the length of your polytunnel, joining sections of 3.2 meter long base rail and securing them to the hoops using clamps,
finishing with a 1.8 meter length if required.
The base rail will exceed the length of your polytunnel and will be cut off later. We will now show you how to fit the base rail from the doorpost to the corner hoop, using a length of timber 2.4 meters long, but one end up to the inside of the corner clamp wing. Make a mark through the hole and another mark where you are required to cut the piece, in line with the doorpost. Drill a hole and cut the timber and then reposition the base rail. Secure it to the corner clamp using a washer and nut. Use a spirit level to make sure that it is level to the doorpost. If your site is sloped, you may be required to dig out a little earth to accommodate this. Use a 4mm timber drill bit to drill a pilot hole in the centre of the inside edge of the doorpost, through into the base rail. Screw a 150mm screw through the hole to secure together. Reinforce the joint from the doorpost to the base rail with a nail plate and square twisted nail. Fit the base rail from the doorpost to the corner on the opposite end of the polytunnel using the same method. Cut the excess base rail down the length, flush with the end of the polytunnel.
We can now fit the base rail on the opposite side. If your ground is not on a slope, then repeat the procedure you followed for the first half. If you have a slope across the width, fitting the rail on this joint will create an unnecessary gap. We advise setting the base rail at a height that eliminates the gap as much as possible, but still ensuring that the rail from the doorpost to the corner hoop is level. Ensure that the rail is at a consistent height. A string line will be handy here.
In this video, we will show you how to install side ventilation without a screen. Here are the parts you'll need. Timber side rails are 47mm by 75mm, commonly known as 3x2, and supplied in lengths of 1.8 meters, 2.4 meters, and 3.2 meters long. The side rail is fitted 75 centimeters above the base rail from the doorpost to the corner, down the length, and returns to the opposite doorpost. It is fitted using the same method as fitting the base rail with corner and intermediate clamps. To get started, measure from the top of the base rail up the hoop and make a mark at 75 centimeters. Fit a corner clamp to the corner hoop. To assemble the corner clamp, place a U-bolt around the corner hoop with the threads pointing towards the inside of the polytunnel.
Place the tube pressing and then corner clamp onto the threads,
ensuring the corner clamp wings are positioned as shown, loosely secure in place.
Locate a 3.2 meter length of timber and position it down the length of your polytunnel so that one end is flush with the end of your polytunnel.
Ensuring the wing of your corner clamp is in the center of the timber and that the timber is on the outside of the corner clamp wing. Make a mark through the hole of the corner clamp wing. Drill a hole through the mark using a 9mm timber drill bit. Push a bolt through the timber and corner clamp, ensuring the thread is on the inside of the polytunnel. Adjust the clamp to the height mark and secure with a nut. To secure the side rail to the intermediate hoop, use an intermediate clamp. Ensure your side rail is to the height mark and drill a hole through the timber on each side of the hoop using a 9mm wood drill bit. Place a bolt through each of these holes from the intermediate clamp. An arch pressing is placed over the bolts and secured in place with nuts. To add another section, you will need to join another piece of side rail to the one you have just fitted. Position a nail plate equally across the joint and secure in place using square twisted nails. You will be required to fit a nail plate to each side of the joint. Work down the length of your polytunnel, joining sections of 3.2 meter long side rail,
finishing with a 1.8 meter length if required,
and securing them to the intermediate hoops using clamps. The side rail will exceed the length of your polytunnel and will be cut off later. We will now show you how to fit the side rail from the doorpost to the corner hoop, using a length of timber 2.4 meters long, but an end up to the inside of the corner clamp wing. Make a mark through the hole and another mark where you are required to cut the piece in line with the doorpost. Drill a hole and cut the timber, and then reposition the side rail.
Secure it to the corner clamp using a washer and nut.
Use the spirit level to make sure it is level to the doorpost, and then use a 4mm timber drill bit to drill a pilot hole in the centre of the inside edge of the doorpost through into the corner rail. Screw a 150mm screw through the hole to secure together. Reinforce the joint from the doorpost to the side rail with a nail plate and square twisted nail. Nail plates are installed on both sides of the joint. Fit the side rail from the doorpost to the corner on the opposite end of the polytunnel using the same method. Cut off the excess flush with the end of the polytunnel. Now we will install a side ventilation net. Ventilation netting is fitted from one doorpost, down the length, and returns to the doorpost on the opposite end of your polytunnel. Roll out the net down the length of your polytunnel. Check that you have enough netting at each end to reach the doorpost. Start at one end, position the ventilation netting so it is flush with the top of the side rail, and staple it in place. If you have ordered timber side ventilation for both sides of your polytunnel, repeat this process on the opposite side. The next part of the process for installing the side ventilation is done once you have fitted your polytunnel cover. This is because during the process of fitting the cover, the rails are raised, the cover is attached, and then the rails are lowered to add extra tension. Finishing ventilation before the cover has been fitted will hinder the process and will result in the ventilation netting becoming baggy. Please watch the video fitting the polytunnel cover to timber rails and then return to this section to perform the final fit of your ventilation netting. After your polytunnel cover has been fitted, you will be required to secure your side ventilation netting to the base rail and doorpost. The ventilation netting is secured to the base rail using battens. To speed up the process, we recommend pre-nailing a number of battens. Nails should be 20 cm apart and should not protrude. Starting in the middle and working out to each end, pull the side ventilation netting down so it is tight and free of any wrinkles and creases. Position a batten flush with the top of the base rail and nail into place. Secure the side ventilation netting to the corner rails using the same method demonstrated earlier. You are also required to install a batten down the door frame post between the base rail and side rail. Pull the netting and secure the batten. Finally, trim off any excess ventilation netting. Repeat this second step on the opposite side of your polytunnel if you have side ventilation on both sides. In this video, we will show you how to fit side ventilation with a screen. Here are the parts you'll need. Timber side rails are 47mm by 75mm, commonly known as 3x2, and supplied in lengths of 1.6 meters, 1.8 meters, 2.4 meters, and 3.2 meters long. The side rail is fitted 75 centimeters above the base rail from the doorpost to the corner, down the length, and returns to the opposite doorpost. It is fitted using the same method as fitting the base rail with corner and intermediate clamps. To get started, measure from the top of the base rail up the hoop and make a mark at 75 centimeters. Fit a corner clamp to the corner hoop. To assemble the corner clamp, Place a U-bolt around the corner hoop with the threads pointing towards the inside of the polytunnel.
Place the tube pressing and then corner clamp onto the threads,
ensuring the corner clamp wings are positioned as shown, loosely secure in place.
Locate a 3.2 meter length of timber and position it down the length of your polytunnel so that one end is flush with the end of your polytunnel.
Ensuring the wing of your corner clamp is in the center of the timber and that the timber is on the outside of the corner clamp wing. Make a mark through the hole of the corner clamp wing. Drill a hole through the mark using a 9mm timber drill bit. Push a bolt through the timber and corner clamp, ensuring the thread is on the inside of the polytunnel. Adjust the clamp to the height mark and secure with a nut. To secure the side rail to the intermediate hoop, use an intermediate clamp. Ensure your side rail is to the height mark and drill a hole through the timber on each side of the hoop using a 9mm wood drill bit. Place a bolt through each of these holes from the intermediate clamp. An arch pressing is placed over the bolts and secured in place with nuts. To add another section, you will need to join another piece of side rail to the one you have just fitted. Position a nail plate equally across the joint and secure in place using square twisted nails. You will be required to fit a nail plate to each side of the joint. Work down the length of your polytunnel, joining sections of 3.2 meter long side rail,
Finishing with a 1.8 meter length if required.
and securing them to the intermediate hoops using clamps. The side rail will exceed the length of your polytunnel and will be cut off later. We will now show you how to fit the side rail from the doorpost to the corner hoop, using a length of timber 2.4 meters long, but an end up to the inside of the corner clamp wing. Make a mark through the hole and another mark where you are required to cut the piece in line with the doorpost. Drill a hole and cut the timber, and then reposition the side rail.
Secure it to the corner clamp using a washer and nut.
Use the spirit level to make sure it is level to the doorpost, and then use a 4mm timber drill bit to drill a pilot hole in the center of the inside edge of the doorpost through into the corner rail. Screw a 150mm screw through the hole to secure together. Reinforce the joint from the doorpost to the side rail with a nail plate and square twisted nail. Nail plates are installed on both sides of the joint. Fit the side rail from the doorpost to the corner on the opposite end of the polytunnel using the same method. Cut off the excess flush with the end of the polytunnel. Now we will install the side ventilation and screen. Ventilation screens cannot operate around corners, and as a consequence, the ends underneath the corner side rail of the polytunnel adjacent to the doors will be fitted with polythene panels. To get started, we will fit the polythene screen down the length of your polytunnel. From the end of the side rail on the length, measure in 20 cm and 40 cm. Repeat this at the opposite end.
The polythene screen will be fitted between the two 20 cm marks. Roll out the polythene screen down the length and position it so one end is on the 20 cm mark. Ensure the polythene screen is flush with the top of the side rail and secure it using staples until you reach the 20 cm mark at the opposite end.
Once you have reached the other end, use a piece of timber to cut the polythene panel to size. Use a straight edge to ensure you get a vertical cut. We will now fit the corner polythene panels to each end. Roll out the polythene panel and position it so one end is on the end of the 40 cm mark and around the corner, leaving it to overhang the doorpost. Ensure the top edge is flush with the top of the side rail and staple the polythene panel to the side rail. Repeat on the opposite end. The ventilation netting can now be fitted. Staple the side ventilation net flush to the top of the side rail.
Ensure the side ventilation net comes beyond each end hoop.
If you have ordered timber side ventilation and screen for both sides of your polytunnel, repeat this process on the opposite side. The next part of the process for installing side ventilation is done once you have fitted your polytunnel cover. This is because during the process of fitting the cover, the rails are raised, the cover is attached, and then the rails are lowered to add extra tension. Fitting ventilation before the cover has been fitted will hinder the process and will result in the ventilation netting becoming baggy. Please watch the video fitting the polytunnel cover to timber rails and then return to this section to perform the final fit of your ventilation and screen. A timber post 47mm by 75mm and 1.6 meters long should be cut to fit between the base rail and the side rail. This needs to be positioned flush to the outside of the end hoop. Secure in position to the side and base rail using the right-angled clamps and screws supplied in the side screen fixing kit. Repeat on the opposite end. We now assemble the gearbox winding system. Decide which end of the polytunnel you wish to have the winding mechanism. The large hole in the faceplate goes to the bottom. Insert 2 nuts into the gearbox housing and fix the gearbox in place using 40mm M6 bolts. Fix the gearbox onto the faceplate so that the eye of the winder is positioned internally. Attach the runner wheels using 2 25mm M8 bolts to the top and bottom holes of the faceplate. Secure in place tightly with a nut on each bolt. Screw the runner wheels onto each thread with the nylon washer visible, ensuring that the thread of the bolt is flush with the face of the runner wheels. Measure and cut the winder track to fit on the corner post between the side rail and base rail. Slide the winder down into the track and screw into position on the inside of the corner post, ensuring that the track is screwed to the inner edge of the post using 35mm long screws. The screen tube is supplied in 1.57 meter lengths and is swaged at one end and plain on the opposite end. The screen tubes slot together. When fully assembled, the tube will exceed the length of your polytunnel. You will be required to trim the last piece to size. Starting with one tube, use a 5mm metal drill bit to drill a hole through the tube, 7 cm in from the end. Locate the drive pin into the tube, align the holes, and bolt together with the 35mm M5 bolt and lock nut. Push the gearbox drive pin into the square drive hole in the gearbox. The remaining tubes should be slotted together. The final piece should be cut 2.5 cm short of the vertical post at the opposite end of the winding mechanism. Finally, secure these tubes together using a self-drilling screw with the provided driver socket 4 cm from the joint. The polythene screen is fixed to the screen tube through the use of clips. In order to aid fixing, it is advisable to trim the polythene approximately 30 cm beyond the base rail. Working from the gear winder end, roll the polythene screen under and around the blind tube. Push the retaining clip onto the screen tube and proceed along the length of the polytunnel, ensuring retaining clips are fitted at each hoop. Fit the remaining clips in a position halfway between each hoop. Slide the hook onto the handle of the gear winder and turn. The gear winder should rise and fall as the ventilation screen opens and closes. If the screen tube needs adjusting, this can be achieved by wrapping more or less polythene around it. With the screen now operational, you can now fix the ventilation net and corner polythene panels to the vertical post, door frame post, and base rail. First, a batten will need to be fitted to the 2 timber posts between the base rail and side rail on the outer face. This batten ensures the winding mechanism does not damage the ventilation netting. From the outside of the polytunnel, lift up the polythene panel and ventilation netting as high as possible. Measure and cut a piece of batten to fit onto the post. It is not required to be the full height. Position this piece on the inner edge of the post and then fix the batten into place with nails. Repeat on the timber post on the opposite end.
To aid fitting the corner panel around the corner, cut the corner panel parallel with the length of the polytunnel. Pull it tight and secure it to the base rail with staples.
We will now secure the ventilation net to the base rail first. The ventilation netting is secured to the base rail using battens. To speed up the process, we recommend pre-nailing a number of battens. Nails should be 20 cm apart and should not protrude. Starting in the middle and working out to each end, pull the side ventilation netting down so that it is tight and free of any wrinkles and creases. Position a batten flush with the top of the base rail and nail into place. Now secure the ventilation netting to the timber upright. Pull the netting tight and secure a batten. The corner polythene panel now needs fixing to the doorpost and base rail. Secure the side panel to the corner base rail and doorpost using battens as demonstrated earlier. Finally, trim off any excess polythene and net. Repeat this second step on the opposite side of your polytunnel if you have side ventilation with a screen on both sides. In this video, we will show you how to apply anti-hotspot tape and silver protection tape on your polytunnel. This self-adhesive foam tape prolongs the life of your polytunnel cover by protecting it against heat buildup from the metal hoops and abrasion during extreme weather. First tunnels would not construct a polytunnel without using anti-hotspot tape. Here are the parts you'll need. Anti-hotspot tape is applied on all hoops. Some of our customers ask whether anti-hotspot tape should be fitted to all metal framework such as the ridge. Although the polytunnel cover may come into contact with the ridge, we only recommend fitting anti-hotspot tape to the hoops, where the polytunnel cover is under a lot of tension. It is very important that the operation is done immediately prior to fitting your polytunnel cover. This process should be done in dry conditions.
Your hoops should be clean and free of dirt and grease.
The adhesive will not adhere to the metal if it is not dry and clean. On the intermediate hoops, fit anti-hotspot tape in a straight line in the middle of the tube, starting and finishing approximately 10 cm above the ground or fixing rails if fitted. On the two end hoops, the polytunnel cover will touch the top and the side of the hoop, as it is tensioned down the end. This means you will be required to position the anti-hotspot tape on the edge where the polythene cover will touch. Silver protection tape can now be applied to the two ends of the ridge assembly. If the twin supports have been installed, then silver protection tape is applied to the ends of the twin supports also. Wrap the silver protection tape around the ends in a figure of 8 motion until all the rough surfaces of the tube have been covered. Each roll measures 4.5 meters in length. Use approximately 2 meters per ridge clamp.
In this video, we will show you how to fit your polytunnel cover to a timber base rail or timber side rail. We also have videos that show you how to fit your polytunnel cover to an aluminium rail. Achieving a tight fit on your polythene cover will result in a better performing polytunnel. Here are the parts you'll need. We'll start by preparing the framework to be covered. The polytunnel cover is secured to the side rail or base rail and around the door frame by trapping it between a rebate batten and a sheeting batten. Battens are 19mm by 38mm timber and come in 1.8 meter lengths, and you will be required to cut them to size. The battens are secured in place using nails.
First, we will fit the rebate batten around the door frame. Rebate battens are fitted so they are flush with the outer edge of the frame. You will require more than one piece of batten and need to cut them to size. Start by fitting a batten to the door frame lintel. Ensure the batten is flush with the outer edges of the door frame posts and secure in place with nails. Now install battens down the door posts. Battens only need to be fitted to 2 outer door posts. If you are fitting your polytunnel cover to a side rail, then the rebate batten needs to fit between the rebate batten fitted to the door frame lintel and the top edge of the side rail. If you are fitting your polytunnel cover to a base rail, then this rebate batten will extend to the top edge of the base rail. Fit the rebate batten to the opposite door frame post in the same way, and then repeat this entire process on the opposite end of your polytunnel.
We will now fit the rebate batten to the base rail or side rail. The rebate batten is fitted to both options in the same way. Please note, if you are fitting your polytunnel cover to a side rail, rebate battens are not fitted to the base rail below. We only fit rebate battens on the rail the polytunnel cover is being attached to.
We need to ensure that when fitted, the sheeting batten does not protrude the bottom edge of the side rail or base rail. We recommend using a spare piece of batten as a spacer. When securing the rebate batten to the side or base rail, position the spacing batten flush with the bottom edge of your side or base rail. Position the rebate batten on the top and secure with nails. Fit battens between the door frame post and corner hoop. Continue down the length of your polytunnel and then around the corner to the door post on the opposite end of your polytunnel.
The corner edges are sharp and could potentially rip the polytunnel cover when you pull the cover over the structure. Remove the sharp corners with a saw. We also install anti-hotspot tape onto the sawn corners to give extra protection. Achieving a tight fit on your polytunnel cover will result in a better performing polytunnel. To achieve a tight fit, we will raise the side or base rail, attach the cover, and then lower it into its original position. If you have ordered side ventilation, the base rail will not need raising. Only raise the rail that your polytunnel cover is being attached to. This process tensions your cover and ensures you have a drum-tight fit. Make a mark on each hoop where the U-clamp is on the corner and intermediate brackets. Then measure up 6 cm and make another mark. Loosen the brackets, lift them to the 6 cm mark and retighten. Repeat this on all hoops. Please note, the nail plate that attaches the corner rail to the door frame post will pivot enough to accommodate this. To help complete this process as quickly as possible, we recommend pre-nailing a number of battens. Ensure the nails do not protrude. Nails should be 10 cm apart. You have now completed all of the preparation and are ready to start fitting your polytunnel cover. Anti-hotspot tape should have been applied to all hoops before commencing the covering operation. Ensure you give yourself enough time to complete fitting your cover. This is not an operation to be undertaken alone. We also suggest that this is done on a calm day as heavy wind and rain will hinder the process. Only begin fitting your polytunnel cover when you are confident that it can be completed without unnecessary interruptions. Although the polythene is very strong and can withstand a lot of abuse, pulling and stretching the cover can sometimes leave finger marks. To avoid this spoiling your polythene cover, try to grip the polythene on the outer edges, somewhere that will be later trimmed or buried into the ground. Check the ground for sharp objects, stones, sticks, etc., which may damage the polythene cover. If you have enough room, roll the cover out down the length of your polytunnel. Each face of the polytunnel sheet is identical. There is not a right and wrong side when choosing which face goes on the inside or outside of the structure. Loosen the folds of the polythene cover. With one person at each end holding a corner,
pull the cover taut and begin to slide the polytunnel cover over the hoops. From the corner of the polytunnel structure, walk across the width to the corner hoop. The cover should slide up and over the hoops smoothly. If you are short on space or have a very long polytunnel, you can roll the polythene cover out on top of the polytunnel from one end to the other. You can then unfurl the polythene cover. Centralize the polytunnel cover over both the length and width of the polytunnel. The cover should reach approximately halfway down the door frames. Don't expect the polythene to reach the ground at the door ends. With the polytunnel cover loosely in position, it is time to start securing it into place. At one end, trap the polytunnel cover under the sheeting batten on the doorframe lintel and secure the 15 cm central section, approximately 3 nails. Do not nail the entire length of the batten to the frame at this stage. Now go to the opposite end of your polytunnel. Pull the cover tight along the length. You will need to get as much tension on the cover as possible. A good approach is to pull the cover down and swing into the polytunnel using your full body weight, whilst your assistant positions the second prepared batten and secures the 15 cm central section, approximately 3 nails. We will now fix the polytunnel cover down the length of your polytunnel to the timber base rail, or side rail if you have ordered side ventilation. In this video, we are fitting the cover to a side rail. If you are fitting your cover to a base rail, the process is exactly the same. Starting in the centre on one side of the polytunnel, fix the cover into the rebate using the 1.8 metre prepared battens, working along until you reach each end. The other side of the polytunnel has yet to be fixed, so simply tension the polythene enough to rid the cover of any creases and ripples. Once one side of the polytunnel cover has been fixed, repeat on the other side using the same method. However, as the cover has been fixed on the opposite side, more downward force on the polythene can be applied to achieve a tight cover. At the corner where the cover has been fitted to the timber rail, below this rail cut the polythene parallel with the end hoop. This frees the polythene at the corner, allowing pleating and fitting to the door frame post. Carefully pull the top door batten slightly away from the doorframe lintel, pull down on the polythene, and begin to tuck the polythene behind the batten. Secure a few nails at a time. Work from the centre to both sides until the doorframe lintel batten is fully secure. Now we will secure the polythene cover to the doorposts. You're looking to achieve consistent pleats. We recommend you do a dry run to gauge the amount of pleats for an even distribution. The pleats start at the centre and dissipate as you reach the straight side of the polytunnel hoop. Position a batten down one of the doorposts and hammer the first 2 or 3 nails in. You will continue to pleat the polythene down the sides. Pull the cover as tight as you can and secure a couple of nails at a time. Keep working down the doorpost. If you are fitting the cover to a base rail, you will secure battens to the bottom of the base rail. If you are fitting the cover to a side rail, only hammer in nails until you are level with the side rail. Repeat this process to secure the cover to the other door. We will now tension the polytunnel cover. The tensioning process is the same whether you are fitting to aluminium or timber rails. Loosen the corner and intermediate clamps and push the rail down to its original position. Then firmly retighten all clamps. Now secure the polytunnel cover to the base or side rails that spans from the doorpost to the end hoop. Measure and cut a piece of the batten to fit. Pull the polythene down and secure in place. Repeat on both sides and then on the opposite side of the polytunnel. It is now time to trim off any excess polythene. Carefully cut the polythene around the door frame. If you had fitted your cover to a side rail, cut the excess along the corners and length. Take care not to cut the ventilation netting. If you have fitted the cover to a base rail, some of our customers choose to bury the polythene skirt.
We will now fit the polythene panels between the inner door frame post and the outer door frame post. Unfold the polythene panel. Make one edge flush with the outer edge of the outer door frame post and secure in place using staples. Pull the panel tight across the width and secure to the outer face of the inner door frame post. Nail battens down the two sides. This will further secure the panels in place. You will be required to cut battens to size. Secure the bottom of the panel to the top edge of the base timber. Pull it tight and secure using staples. Further secure with a batten. Finally, pull the panel tight to the top and secure using staples and battens. Trim off any excess polythene.
Repeat this process for the 3 remaining panels. You have now completed the process of covering your polytunnel.
In this video, we will show you how to fit your polytunnel cover to an aluminium base rail or aluminium side rail. We also have videos that show you how to fit your polytunnel cover to a timber rail. Achieving a tight fit on your polythene cover will result in a better performing polytunnel. Here are the parts you'll need. We'll start by preparing the framework to be covered. The polytunnel cover is secured to the side or base rail by trapping it in the channel and using the profiles provided. The polytunnel cover is secured to the door frame by trapping it between a rebate batten and a sheeting batten. Battens are 19mm by 38mm timber and come in 1.8 m lengths, and you'll be required to cut them to size. First, we will fit the rebate batten around the door frame. Rebate battens are fitted so they are flush with the outer edge of the frame. Start by fitting a batten to the door frame lintel. Ensure the batten is flush with the outer edges of the door frame posts and secure in place with nails. Now install battens down the doorposts. Battens only need to be fitted to 2 outer doorposts. If you are fitting your polytunnel cover to a side rail, then the rebate batten needs to fit between the rebate batten fitted to the door frame lintel and the top edge of the side rail. If you are fitting your polytunnel cover to a base rail, then this rebate batten will extend to the top edge of the base rail. Fit the rebate batten to the opposite door frame post in the same way, and then repeat this entire process on the opposite end of your polytunnel. Achieving a tight fit on your polytunnel cover will result in a better performing polytunnel. To achieve a tight fit, we will raise the side or base rail, attach the cover, and then lower it into its original position. If you have ordered side ventilation, the base rail will not need raising. Only raise the rail that your polytunnel cover is being attached to. This process tensions your cover and ensures you achieve a drum-tight fit. Make a mark on each hoop where the U-clamp is on the corner and intermediate brackets.
Then measure up 6 centimeters and make another mark. Loosen the clamps, lift them to the 6 centimeter mark and retighten. Repeat this on all hoops. Please note, the side rail will pivot enough to accommodate this where it is attached to the door frame post. The polytunnel cover will be trapped between the rebate batten and the sheeting batten around the door frame. To help complete this process as quickly as possible, we recommend pre-nailing the door frame battens. Ensure the nails do not protrude. Nails should be 10 centimeters apart. You have now completed all of the preparation and are ready to start fitting your polytunnel cover. Anti-hotspot tape should have been applied to all hoops before commencing the covering operation. We also recommend installing anti-hotspot tape on the corners of the rail. This will add extra protection so you will not damage your cover when pulling it over the structure. Ensure you give yourself enough time to complete fitting your cover. This is not an operation to undertake alone. We also suggest that this is done on a calm day, as heavy wind and rain will hinder the process. Only begin fitting your polytunnel cover when you are confident that it can be completed without unnecessary interruptions. Although the polythene is very strong and can withstand a lot of abuse, pulling and stretching the cover can sometimes leave finger marks. To avoid spoiling your polythene cover, try to grip the polythene on the outer edges, somewhere that will be later trimmed or buried into the ground. Check the ground for sharp objects, stones, sticks, etc., which may damage the polythene cover. If you have enough room, roll the cover out down the length of your polytunnel. Each face of the polythene sheet is identical. There is not a right or wrong side when choosing which face goes on the inside or the outside of the structure. Loosen the folds of the polythene cover. With one person at each end holding a corner, pull the cover taut and begin to slide the polytunnel cover over the hoops. From the corner of the polytunnel structure, walk across the width to the corner hoop. The cover should slide up and over the hoops smoothly. If you are short on space or have a very long polytunnel, you can roll the polythene cover out on top of the polytunnel, from one end to the other. You can then unfurl the polythene cover. Centralize the polytunnel cover along both the length and width of the polytunnel. The cover should reach approximately halfway down the door frames. Don't expect the polythene to reach the ground at the door ends. With the polytunnel cover loosely in position, it is time to start securing it into place. At one end, trap the polytunnel cover under the sheeting batten on the door frame lintel and secure the 15 cm central section, approximately 3 nails. Do not nail the entire length of the batten to the frame at this stage. Now go to the opposite end of your polytunnel. Pull the cover tight along the length. You will need as much tension on the cover as possible. A good approach is to pull the cover down and swing into the polytunnel using your full body weight, whilst your assistant positions the second prepared batten and secures the 15 cm central section, approximately 3 nails. We will now fix the polytunnel cover down the length of your polytunnel to the aluminium base rail or side rail if you have ordered side ventilation. The other side of the polytunnel has yet to be fixed, so simply tension the polythene enough to rid the cover of any creases and ripples. Starting in the centre of one side of the polytunnel, fix the cover by pressing the U-profile into the channel. If fitting to a side rail, use the top channel. You will be required to cut the profiles to size. Work to both ends, adding sections as you go. Once all the U-profiles are in place, use a rubber mallet to hammer the T-profile into place, ensuring it covers any joins in the U-profile. Once one side of the polytunnel cover has been fixed, repeat on the other side using the same method. Too much tension will make it difficult to insert the U-profile. Lessen the tension as required to aid fitting. At the corner where the cover has been fitted to the aluminium rail, below this rail, cut the polythene parallel with the end hoop. This frees the polythene at the corner, allowing pleating and fitting to the door frame post. Carefully pull the top door batten slightly away from the door frame lintel.
Pull down on the polythene and begin to tuck the polythene behind the batten. Secure a few nails at a time. Work from the centre to both sides until the doorframe lintel batten is fully secure. Now we will secure the polythene cover to the doorposts. You are looking to achieve consistent pleats. We recommend you do a dry run to gauge the amount of pleats for an even distribution. The pleats start at the centre and dissipate as you reach the straight sides of the polytunnel hoop. Position a batten down one of the doorposts and hammer the first 2 or 3 nails in. You will continue to pleat the polythene down the sides. Pull the cover as tight as you can and secure a couple of nails at a time. Keep working down the doorpost. If you are fitting the cover to a base rail, you will secure battens at the bottom of the base rail. If you are fitting the cover to a side rail, secure a batten down to this rail. Repeat this process to secure the cover to the other door frame. We will now tension the polytunnel cover. When covering is complete, loosen the base rail or side rail clamps. Push the aluminium rail down to its original position to tension the cover and retighten the clamps. Now secure the polytunnel cover to the base or side rail that spans from the doorpost to the end hoop using the U and T profiles as described earlier. It is now time to trim off any excess polythene. Carefully cut the polythene around the door frame. If you have fitted your cover to a side rail, cut off the excess along the corners and length. If you have attached the cover to base rails, some of our customers choose to bury the polythene skirt. We will now fit the polythene panels between the inner door frame post and the outer door frame post. Unfold the polythene panel. Make one edge flush with the outer edge of the outer door frame post and secure in place using staples. Pull the panel tight across the width and secure to the outer face of the inner door frame post. Nail battens down the 2 sides. This will further secure the panels in place. You will be required to cut battens to size. Secure the bottom of the panel to the top edge of the base timber. Pull it tight and secure using staples. Further secure with a batten. Finally, pull the panel tight to the top and secure using staples and battens. Trim off any excess polythene. Repeat this process for the 3 remaining panels.
You have now completed the process of covering your polytunnel.
In this video, we will show you how to secure your hoops to your foundations. Here are the parts you'll need. Securely fixing your polytunnel hoops to your foundations prevents the unlikely circumstance of a hoop lifting in heavy winds. This task should be completed once the process of tensioning the polytunnel cover has been completed. For the foundation tubes, drill a self-tapping screw through the tubes where the hoops overlap the foundation tubes. Please note, due to the length of the swage, ensure that the position of the screw is no higher than 4 cm above the joint. For hoops fitted to screw anchors or base plates, position the screw no more than 10 cm from the bottom of the hoop. Take extra care as not to slip and damage the polytunnel cover. Repeat this process on all foundations. In this video, we will show you how to install irrigation on your polytunnel. Here are the parts you'll need. The irrigation tube is supplied in one reel, which will need to be cut to size. First, we install the straining wire that is used to support the irrigation tube. Be careful when handling this straining wire as not to puncture a hole in your polytunnel cover. There will be 3 lines of straining wire. You should install one length of straining wire down the center of your polytunnel. The other 2 should be equally distanced from the center and the side of your polytunnel. Start by taking one end of the straining wire and wrapping it around the door rail at one end of your polytunnel. Twist the wire to secure it. Unravel the wire and pull it down the length of your polytunnel to the opposite end. Ensure the wire runs under the crop bars if installed. Cut the wire, ensuring the length reaches the opposite door rail with an additional 30 cm, which will be used for securing to the wire strainer. Now cut a piece of straining wire approximately 40 cm long. Slide this piece through the straining wire tensioner using the holes on the flat prongs. Wrap the wire around the door rail and then twist to secure. Trim any excess. Use of pliers may be helpful with this next process. Locate the end of the wire that runs down the length of your polytunnel. Feed the wire through the external hole of the tensioner and into the hole within the central pin. Feed through all the wire, eliminating any slack. Using an 8mm spanner, begin ratcheting. The wire strainer will begin to restrict this process. At this point, cut the wire to allow clearance for further ratcheting until the wire is fully tensioned. Use cable ties to secure the straining wire to each crop bar if ordered. If crop bars are not being used, to support the wire at the point where it passes below an intermediate hoop, cut a length of wire 30 cm longer than the gap between the underside of the hoop and the straining wire. Bend this wire at one end into a small loop and using a cable tie through the loop, fix this wire to the hoop. Bend the other end around the full length of straining wire, ensuring the wire is at a level position. Now position supporting hooks down the length of the straining wire. The support hooks should be positioned at 60 cm spacings. Repeat this process to install the 2 remaining straining wire supports. We will now start to install the irrigation pipe. First, you will want to decide where you want your water supply to enter your polytunnel. You will fix the tap to the nearest intermediate hoop. A central position is ideal, as this system allows 6 zonal areas to be operated independently should low water pressure not allow the whole area to be watered at one time. Assemble the inlet system. Take note of the water flow arrows stamped on the filter. Ensure the water flow follows the arrows. PTFE tape should be placed around the thread end of the filter and the thread end of the ball valve. If the pipe is stiff, you can place the end of the pipe into boiling water to soften. Use cable ties and begin fixing the inlet system and connected pipework to the chosen intermediate hoop. Position the inlet system at a suitable height for ease of access, taking into consideration any staging or shelving that may be fitted. Continue securing the header pipe to the polytunnel hoop using cable ties, approximately every 1 meter until you are vertically above the first straining wire. At this point, cut the pipe. Cut a length of pipe that approximately fits between the straining wire and the hoop. Onto one end of this connecting pipe, position a coupling nut, insert a grip ring, and secure to the T-piece. Then, onto the header pipe, position a coupling nut, insert a grip ring, and secure to the T-piece joining the two pipes. From the first T-piece, continue installing header pipe to the underside of the hoop. Upon reaching the next straining wire, insert a T-system as described previously. Continue installing the header pipe to the underside of the hoop, and upon reaching the final straining wire, use the same method, however, an elbow piece replaces the T. Assembly of the T-piece and ball valves. Connect a ball valve to each end of the T-piece as shown. Repeat this to assemble 3 units. At the end of the 3 vertical connecting pipes, position a coupling nut, insert a grip ring, and secure to the T-piece and ball valve assemblies. Now you will install 6 lengths of overhead spray lines from the T-piece and ball valve assembly. Onto one end of the remaining irrigation pipe, position a coupling nut, insert a grip ring, and secure to the ball valve. Use the supporting hooks to securely attach the irrigation pipe to the straining wire and cut once you reach 5 cm from the end of the polytunnel. Repeat this process a further 5 times. On each end of the overhead spray lines, you will need to fit a plug. Position a coupling nut, insert a grip ring, and secure to the male plug. We will now assemble the down tube assembly. Assemble all the down tubes as shown. To install the down tube assembly, use a hole punch to punch a hole into the irrigation pipe. Punch a hole into the underside of the spray line centrally between each hoop and then simply push the down tube assembly into the hole. Repeat this process to fit the remaining down tube assemblies. If you ordered a Prestige irrigation system, then you will need to fit the water controller onto the tap of your water source. The water controller is supplied with fittings for either a 3/4 inch or 1 inch male threaded tap. Use the 2 hose to female click fittings to run a hose between the male click fittings on the water controller and the polytunnel. You will require a hose pipe and may require extra click fittings depending on the type of tap being used. If you find you do not have sufficient water pressure for the anti-drip valves to operate, these can be eliminated from the system. Your system is now ready. You can find more videos to help you build your polytunnel and construct.firsttunnels.co.uk. We also have a construction helpline if you require any further assistance.